Okay, so our second transformation we're going to talk about is a reflection. And a reflection, remember we talked about the translation, it preserves orientation, so it's going to be facing the same way. The reflection, it does not preserve orientation. So it's going to be turning different ways, hence the name reflection. So it's going to look a little bit different, kind of as in when we get to rotations as well. Another thing I want you to note on this is that this is referred to as an isometry. Translations and reflections are all isometries in that they preserve the size. So isometries preserve the size, and again, that's translations, reflections that we've talked about so far, and we'll get to rotations as well. So they all preserve the size of your pre-image. Again, this one, though, does not preserve the orientation. All right, so a reflection, it's going to use a line, very similar to a mirror, and what's going to happen, it's going to reflect an image. The mirror line is called the line of reflection. So to reflect, we're going to reflect across the x-axis. So make sure you remember your axes correctly. So this is the x-axis. So a reflection is an exact copy of a coordinate away from the line of reflection. So since you're reflecting across the x-axis here, the coordinates are going to be the same distance away from that line. So what I'm meaning is that this coordinate A is right on your line of reflection. So to reflect it over that line, it's not going to move. So A is going to stay right where A is at, and currently it is at -3, 0. And since it is on the line of reflection, then the prime, A prime, is going to be the same exact point. Now let's look at B. Point B, if you count here, is 2 units away from the line of reflection. So if we count 2 units in the other direction, and we go up 2, then our B is going to land there, our B prime, which is at 1, 2, 3, 2. So basically, the original was at 3, -2, and B prime was at 3, 2. Now C, you count how far it is away from the line of reflection, and it is 1, 2, 3 units away from the line of reflection because we go straight to the line of reflection. So that coordinate C is at 1, 2, 3. It looks like B is at 1, 2, 3, 4. Sorry, these lines are hard to see. Why did I do this? So, C is at 3, 3. So, since C is 3 away, I'm going to go 3 the other direction, and it's going to land there. So, C prime is going to be at 3, -3. So what I'm talking about is what's the rules. I want you to look at these ordered pairs. So look, this was at -3, 0. It stayed at -3, 0. -4, -2, and then it went to 4, 2. This one was at 3, 3, and then it went to 3, -3. So what I want you to find out for the rule is, look, your y's are opposite from what they started. So in your pre-image to your image, your y's are opposite. So basically there's a rule that you're going to need to memorize for reflecting over the x-axis. And that rule is you take your original ordered pair and you change it so that the x stays the same and the y is opposite. So you really need to be careful when listen to how I say, this does not mean negative, that means opposite. All right, so in number 2, we're going to reflect triangle XYZ across the y-axis. So remember, this is the y-axis, so here is our line of reflection. So to reflect, the points are going to be equidistant away from that line of reflection. So here are your x coordinates. Your x is at 2, 4. Well, if you go straight to the line of reflection, it's 2 away. So you're going to mimic that distance and go 2 on the other side, and that's going to end you up at x prime. So you can see there, then we ended up at negative 2, 4. So let's look at another coordinate at y. Y is at 6, 2. It is 1, 2, 3, 4, 5, 6 units away from the line of reflection. So we're going to go 6 in the other direction. And there is going to be our y prime. And there it is at negative 6, 2. And our last one is z. It is 2 away, so if we go 2 away in the other direction, there is our z prime, and it is at negative 2, negative 5. And there is your image. Now again, let's look at the rule. So let's look at the change. Our x's are 2, 6, and 2, and then we went negative 2, negative 6, negative 2. And then our y's are 4, 2, negative 5, 4, 2, negative 5. So the y's stayed the same. The x's were the one that are opposite. So your rule, again, that you're going to need to memorize for a reflection over the y-axis is that your original ordered pair is going to change so that the x will be opposite and the y is going to stay the same. So reflect over the x-axis, x stays the same. Reflect over the y-axis, y stays the same. And again, this symbol does not mean negative, it means opposite. All right, so in number 3, we're going to reflect triangle RST across the line y equals x. And you can see there that the line is drawn for you. Now, that line is not going to be drawn for you every single time, so it is your job to remember that y equals x is this line right here. Remember, it's also referred to as the parent function. So if you're reflecting across, any line, it is your job to know how to graph the line. You can't say, oh, I don't remember how to graph that. It is your responsibility. So that is the parent function. Remember, you're going through the origin 0, 0. That's why there's no y-intercept. All right, when you're reflecting across this line, however, it is a diagonal line. In this one situation, it is okay to count diagonally through the graph if you're reflecting. So if you start with point S and you're going to count that it's kind of, you see there, it's 1.5 away from your line of reflection. If you go, all right, 1/2 and 1 away on the other side, then you're going to end up 1.5, 1.5. Right there is going to be your S prime. And that is to negative 1. Same thing, you can count R, how many blocks it is away. 1, 2, 3, 4, 5. So go 5 the other direction. 1, 2, 3, 4, 5, and there is your point right there. So that is going to be at 1, 2, 3, 4, 5, 6, 1, 2, 3, 4 is your R prime. So it's at 6, negative 4. And same thing with T, you can count 1, 2.5 away. So if you go the other direction, 1, 2.5 away, there is T prime. So again, your job is to, let's think about the rule. Here's the original ordered pair, negative 4, 6, and then when we reflect it across the parent function, 6, negative 4. Do you see the connection there? What has happened is the x and y have just flipped. So the rule for reflecting over the y equals x, the parent function, again, remember, these rules are your job to memorize, is that your original xy is going to change so that the y becomes the x and the x becomes the y. So all they're going to do is switch spots to reflect over the line y equals x. All right, now number 4, you're going to reflect triangle LNM across the line y equals negative x and name the coordinates. So this line is the opposite of the parent function. So again, you're going to need to know how to graph that. I'm going to show you this one time to review and refresh your memory. If you need help on algebra, you're going to have to come in outside of class time to get help on the algebra. All right, so we're going to start at 0, 0 because there is no y-intercept. And if we have a negative x, that means our slope is negative 1 over 1. So basically, you're going to go up 1 and over 1. And this is the line y equals negative x. So we're going to reflect across that. So let's first find the coordinates of LMN. So when you're reflecting across the opposite of the parent function, y equals negative x, I'm going to go ahead and give you the rule, and then we're going to apply the rule to the original coordinates and get our new coordinates. So the rule for reflecting over y equals x is you take your original ordered pair and you change it so that the opposite of the y becomes the x and the opposite of the x becomes the y. Again, this does not mean negative. It means opposite, so that's going to confuse you. So you'll see why I wanted to go ahead and give you this rule so you can apply it to these coordinates so you can understand the opposite. So this ordered pair right here, the opposite of the y is going to become the x. So the opposite of negative 4 is 4. The opposite of negative 8 is 8. Again, here, this y is going to become our x, so the opposite of that y becomes our x. The opposite of this x becomes our y. The opposite of this y, again, so the opposite of negative 8 is 8. The opposite of negative 2 is 2. So there are your coordinates for that triangle being reflected across y equals negative x. And there's your triangle L prime, M prime, N prime. All right, let's look at a little practice questions. Which point is the reflection of negative 3, negative 2 over the y-axis? So again, you're going to have to memorize these rules, but if you're reflecting over the y-axis, what happens is the y stays the same and the x is opposite. So they took this original ordered pair, negative 3, negative 2, and we have to say, okay, reflect across the y. That means the y stays the same and the x is the opposite. So this should be 3, negative 2. B. Number 2, which point is a reflection of negative 4, negative 3 over the x-axis? So the rule reflecting over the x-axis is that the x is going to stay the same and the y becomes opposite. So if I take negative 4, negative 3, the x has to stay the same and the y becomes the opposite. So negative 4, 3. Which point is the reflection of negative 3, negative 2 over y equals x? So the rule for flipping over the parent function is that the y becomes the x and the x becomes the y. So you're just going to flip-flop these things so that you're at negative 3, negative 2. Next, number 4, reflect over the x-axis, and number 5, reflect across the y-axis. You're going to do on your own. I expect to see the ordered pairs listed like they are here and the picture drawn. To receive full credit, you need picture and the ordered pairs, so your job to finish. Good luck.